The next week. Yeah. That's my bad. I love you. I love you. I love it. That was they were lying, but I want to chill. Oh, I like it. Okay, guys, let's get started. So we're getting started with 4 examples, which is a bit of a recap from last time. The last thing we did was showing how to add, subtract numbers in binary, starting with decimal, because in decimal these things are easy. For example, number 1, we know the answer is 14. We do this in binary. If you convert 5 to binary and then 9 to binary, get an answer in binary. The binary answer should correspond to 14, right? The binary and decimal must give you the same answer. So do these 4 and check, get the same answer in decimal and in binary. And remember, if we're dealing with negative numbers, we have to use 2's complement to convert to binary. Okay, so a lot of layers in these few examples, a lot of recap needs to be done. First, you guys can go back to your notes, check what you need to. And if you're still struggling, then I'll help you guys. Yeah. What the last thing? I can change one from first. Because in years now. Like what? I'm personally. You know how to do this. Sounds curious. It's not about you. It's just so yeah, First, you know, so we'll say finally balance. Okay, you can just write it. We can so that 5 divided by 2.
Please don't touch it. Which is my pain to begin. Yeah, that's the names of the fires. Well, this is mine. And then I'm sorry, so that means 2 with the remainder of 1. Okay, I think that's
2.5 is 2 with some degree. If you have any of these, that's how it's like. It's always 1.
now.
And the 2 doubles give it. So when each say, we'll say down 2 divided by
Oh, shit. I didn't know. First one is
It's like the ones you know whenever you go. So the thing I guess and the same thing that falls.
isn't it?
Well, so.
Oh, you're trying to do stuff. Yeah.
How do you even get there?
So just like the 0.
Why do you pet?
That's why it's there.
That's your beach. Beach wants to invest.
But I thought it was fun.
Yeah.
What's your size?
So we reached.
So, yeah, colors of fire.
Yeah, so now the 5 is nice.
So convert from a 5 convert a nice pattern line is because at the same system.
Yeah, we can.
This month. Let's just manage my name.
No.
Today the 5 the 9. That should you be
You know, I don't have any example.
I do have a converting. See, I convert that to binary. To show that there's a binary. Okay, yeah, I just add one in binary.
Add them together.
Oh. Let's see. I didn't
Well, it's good to represent it using 8 bits. That's a standard.
So.
We got 3 bits. So what you can do is you can add 5 zeros to the front, so it becomes 8 bits.
One thing this way.
The choice is yours.
So we need to add 8 bits. 8 bits, always.
Always. Unless they tell you otherwise. Okay, guys, if anybody's lost, I'm going to do number 1. If you need the recap, I'm doing that now on the board.
Okay.
All right, so let's change color to red. Make a space. Okay, so it's always good to have a calculator out when you're doing these.
Actually.
Okay, so before we add these two numbers in binary, we need to convert them to binary. So 5 and 9. I'll start with guys, please. I'm trying to explain something. We'll start with the 5. So I'll do that here. The 5, we say 5 divided by 2. That gives us 2.5. That is 2 remainder 1. you. Oh, that's it. Sort that out.
Thank you, Rep.
All right, so that's the first step. Remember, we just keep dividing by 2. I'm going through this bit quickly, but if anyone has forgotten how to do this, just ask me. I'll slow down. Okay, so 5 divided by 2 gives us 2.5. 2.5 is 2 with some remainder. As long as we have any remainder, we write remainder 1. That's what the 2-1 means. 2 with the remainder of 1, right? Then with our new number, which is 2, we do the same thing. We divide it by 2. Answer is going to be 1. Let's do that again, is 1. And that's 1 with no remainder. So 1-0. Right, there's no remainder there, so we write -0. Then we take our new answer, which is 1. We do the same thing, divide by 2. That will give us 0.5. So that is 0 with a remainder of 1. Right, so once we hit 0 here, then we stop. Once we reach 0 here, then we stop. There's nothing further to do. So the answer is read from bottom to top. So I'll write it here like this. That first, that second, that third. So that's 1, 0, 1. That's 5 in binary. Right, but remember, we always like to use 8 bits. If not specified how many bits we use, we always want to use 8 bits. That's only 3. Right, so that's not good. So we make that into 8 bits by just adding zeros to the front. So 1, 0, 1 is 3 bits. Make it 4 bits, 5, 6, 7, 8. So that's what we want. That's 5 in binary. So I'll put that here as a little summary. 5 in binary is given by that. Okay, now let's do the same thing to work out what 9 is in binary. Okay, and again, I gave you easy numbers 5 and 9 because you could actually spot something from the numbers and skip all of this work. I'm not going to do that just yet since we're recapping. I'll show you guys that in a moment if anyone's interested. Let's just do it the long method for now. So convert 9 to binary. Take 9 divided by 2. You will get 4,5, which is 4, remainder 1. Then we do the same thing for the answer here, which is 4. Take the 4 divided by 2. You get 2, and that's 2 with no remainder. Take the 2 divided by 2. You get 1, and that's 1 with no remainder. Then you take our answer 1 divided by 2. You get 0,5. That is 0 with a remainder 1.
Oh, yeah.
And once we reach 0, we stop. So again, reading the number bottom to top, the answer will be from here, then there, then there, then there. That's 1, 0, 0, 1. But we want this using 8 bits, right? That's only 4 bits. We want 8 bits, so I'll add zeros to the front of the number. So that's 4 bits, that's 5, 6, 7, 8. So that is 9 in binary. And we can check these as well before we go on, because all of these correspond to powers of 2. So we can see if it actually works up to 9. Right, so that's 2 to the 0. 2 to the 1 doesn't exist because of the 0 there. And 2 squared doesn't exist. 2 cubed is there. So we've got 2 cubed and 2 to the 0. 2 cubed is 8. 2 to the 0 is 1. 8 plus 1 gives us 9. So that's fine. That works out. On top, we have 2 to the 0. 2 to the 1 is not there. 2 squared is there. So 2 squared is 4. 2 to the 0 is 1. 1, 1 gives us 5. So that's fine. So that works out. So now adding 9 and 5 in decimal, we can do that easily. We can do that with our eyes closed. That's not a problem. So I'll just write here. 9 plus 5 in decimal gives us 14. Now adding these two binary numbers together does give us 14. We should. Let's check. Okay, so this is how we add these two numbers in binary. I'm just going to put an arrow here and an arrow here. At the top, I'll write the 5. 1, 2, 3, 4, 5, 101. At the bottom, I'll write the 9. 2, 3, 4, 1, 0, 0, 1. And again, here we just do the old-fashioned method of adding. Remember, there's only 4 possible things that can happen here in binary. I'll recap those things here on the side. If we get 0 plus 0, we will get 0. 0 plus 1 will be 1. 1 plus 1, usually we will get 2 for this, but in binary there is no 2. So it goes up to 10. That's the next thing. And 1 plus 1 plus 1 is going to be 10 plus 1, which is 11. So these are the only 4 things that can happen when we add in binary. So using this, let's see if we can add these numbers together using our old-fashioned method of adding. Okay, so on the extreme right, we have a 1 plus 1, which will give us 0. Sorry, it gives us 10, but I'll write the 10 as a 0 carry 1. Right, just like we used to do in primary school, but now it is binary. So 1 plus 0 is 1. 1 plus 0 is 1. 0 plus 1 is 1, and the rest are all zeros. So there's nothing that happens there. It's just 0, 0, 0, 0. Okay, now I haven't done this before. I'm trying this with you guys for the first time, so let's hope it works out. Right, this is on video, so if it doesn't work out, that's not good. Okay. So anyway, let's see. Does this give us 14? Let's check. 0, 0, 0, 0, 1, 1, 1, 0. That's the answer. Does that give us 14? I think so.
Yeah.
This is, yeah, it's looking good, right? That's 2 to the 1 plus 2 squared. What is it? Plus 2 cubed. Okay, so that's going to be 2 plus 4 plus 8, 9, 10, 11, 12, 13, 14. Okay. Okay, so thank goodness that works out.
When I was working out, I think it would other bits. I still got the same answer. So if I was to do that,
Oh, no, you wouldn't. That works out. But when doing negative numbers, then it might not work.
so we need to add them.
Just say
to make it.
Always safer to do that. Okay, now do you guys think you can try the rest of the examples by yourself? Is anyone done already? Okay.
Yeah, it's not about, you don't need to say, you know.
If you guys want to take this down and take a picture, do that now, so I can scroll away. The last part, check. Everything else is okay. Yeah. Okay, perfect. This teaching part. So here, just every point represents 2 units of something. That's a list of 0, 2 to the 1, 2 squared, 4, 5, 6, 7. All the different powers. So only something with a 1, because yeah, the ones with the 0 are maybe. So 2 to the 0 is not here. 2 to the 1 is the first one. Then 2 squared. Still 2 cubes. 2 to the 4 is not there. 5, 6, all those powers. That's like yeah. Yeah, sure. No problem. There's many times that they go to I don't care about yeah, that's good. You know, yeah.
That's one. It's basically just on the wall on that one. I thought it's the one. We did this, no, yeah, like it's something bad. That's the real extension. I didn't see it. I saw all of them. Some of the side have been given. The side of the I didn't was not sure, but yes,
It just reminds us.
I don't think that's right. You can wake up your bed. That's so good. Bro, what's in the speaker? Your house has enough light. Yeah.
Oh, no.
It's going around. It's going around again. What is? Wait, what? What is it now?
Sharing screen or what?
I think I'm still good.
No, so no.
I think I'm still good.
Which number you want?
3.
Oh, we're all on the first.
Easy. Not.
Yeah.
Sir, number 3.
Yeah, we'll do number 2 quickly, then I'll get to 3.
Okay.
Okay, guys, so starting with number 3 and 4, that's okay. Those are a little bit tricky. Percent I just all of that. Okay, guys, so number 2, I want to quickly show you a very quick method to convert a number to binary. Again, I don't want to confuse anybody, so if this is not working for you, just ignore it. Right, but using our division by 2 method always works. So be safe if you're not sure. But a number like this, I've given an easy number deliberately because you can immediately spot this as a sum of base 2 numbers. Right? Can anyone tell me what numbers add together to give me 10? What base 2 numbers add together? Can anyone see? 8 and 2. Perfect.
2 cubed.
Exactly. Exactly. Right. So with 8 and 2, we can do this very easily. This is how you can write this, just to get the structure right. I'll write on the top here 2 to the 0, 2 to the 1, 2 squared, 2 cubed, and so on. We don't have to go too far with this. I'm just going to put it up to 8 bits since we're working with 8 bits. Right, so that will be up to 2 to the 7, 5, 6, 7. Right, and as you guys mentioned, we need an 8 and we need a 2. So 8 is here, 2 cubed is 8, 2 is here, 2 to the 1. So those are the only two that exist here. 2 cubed, I'll put a 1 under that. 2 to the 1, I'll put a 1 there. Everything else is just a 0 because it doesn't exist. So 0, 0, 0, 0, 0, 0. So that's the answer. That's the binary number right here. So if you can spot this as some combination of base 2 numbers, you can use this method. Makes things much quicker. And if you guys did it using the division by 2 method, you'll see you get the same answer. Right? Anyone who's done that. So if you're more comfortable with that, please stick with that. That also doesn't take too long. This one here, it's possible to make mistakes. So unless you're 100% sure, don't use this method. Okay. So that's 10 in binary. The other number we need is 5. No, sorry, it's 6. I guess we can do the same trick for 6, right? Because we can spot that as a sum of base 2 numbers. Can anyone tell me what base 2 numbers I add together to get 6? 24. Exactly, right? 2 and 4. So where do we find those here? Well, 2 is just 2 to the 1. So that one exists. 4 is just 2 squared. So that exists. Everything else is just 0. Right? 0, 0, 0, 0, 0, 0. Okay, so now can we add these numbers together? This looks like an easy one, actually. Right, so let's do that. In fact, the structure is such I can just do it here, but let me not do that. Let me not do too many things in one go. I'll write the numbers here. 3, 4, 1, 0, 1, 0, 0. Okay, add them together. Again, only 4 things can happen here. So 0 and 0 is 0. 1 and 1 is 10. So 0 carry 1. 1 and 1 is 10 again. 0 carry 1. 1 and 1 is 10. 0 carry 1. And that's just 1. 0, 0, 0. Is that what you guys got? Okay, perfect. And to check our answer, that answer is going to be 2 to the power 0, 1, 2, 3, 4, 2 to the 4, which is what? That's 16, right? So does that correspond to adding 10 and 6? Yes, it does. That's how we check our answer. In decimal, we add these two numbers together, we get 16. In binary, we add them together, we get that, which happens to be 16. So either way, we find. Okay, am I losing anybody yet? Okay, so this stuff is straightforward, that's good. So 2's complement subtraction is where we might get a bit lost. So number 3 is 9 minus 5. Let's make space for that. Okay, so 9 minus 5. Now the way we get around this in binary, since we know how to add, we'll stick with adding. So I'll write this as 9 plus minus 5. So we can add, but now we need to know what minus 5 looks like in binary. And do you guys remember the 2 complement method? If you don't remember in detail, it's okay. Does it kind of sound familiar? Yes, okay. I got 1 yes. Anyone else? Am I speaking another language or does it sound familiar?
Yeah, it does.
Okay. You guys remember the words? Remember when I was standing here talking nonstop and you guys were doing other stuff? Probably then, right? Okay. It's a joke, guys. Okay. Okay, so what we need to do is find out what minus 5 looks like in binary using 2's complement. 9 is fine, we can do that easily. In fact, I think we have at some point, didn't we? In the first one. Okay, so we did that already. So the 9 is fine. Let's do the minus 5. So I'll write here on the side, minus 5. And there were 3 steps to doing this. Step 1 was to convert 5 itself to binary. So I'll just write that here. Convert 5 to binary. And I think we've done that already as well. So let me just copy that answer from the top. What was 5? Okay. 1. Step one is to just convert +5 to binary. Step two was to invert all the digits. So zeros become ones and ones become zeros. Step two is to invert all digits. I'll just invert digits. So am I going too fast for anybody?
No.
So step two was to invert all the digits. Step three was to add 1 to this number. Add a binary 1 to this number. Add 1. Okay, so I'll do that down here. That will be 1 1 1 1 1 0 1 0. Again, we can do this the quick way, or we can do this the slightly longer method. I'll do it a slightly longer method. Okay, let me make more space. That's a bit untidy. Let me just write that a bit bigger. So 1 1 1 1 1 0 1 0. Right, so we add 1 to the result using the method we know how to add, and that's straightforward, right? I'll do this one quickly. 0 and 1 gives us 1, and we just get 1 0. Step 3. Well, there are only 3 steps. Yeah, so that's it. So let's maybe summarize that at the bottom. So -5 in binary is given by the result here. Finding a negative number in binary is a little bit of a hassle. 3 steps to remember to do that. But once we do that, then we can complete the question. Okay, I'll give you guys a moment if you're writing that down. Let me try and not take it off the screen. So now we can work out 9 minus 5 by saying 9 plus -5. So just take 9 and add it to this thing here, this result down here. So I'll give you guys a moment to take that in.
Especially more so you get set out of this device.
Your question directed to me. Sorry. Yeah, yeah.
What does it say?
Yes. I think -1 was converting 2's complement back to decimal. That was the reverse direction.
Oh,
Yes.
the question of the 5 plus -9. Because the original question was 5 minus.
It's possible I wrote the wrong thing. Let's check.
Yeah, what should we use?
We're fine. Okay. All right. No worries. I make mistakes, so you guys are allowed unlimited mistakes as well. Don't stress. As much as I can, let it go. Yeah. Some people for lectures name, they write their own name, and I still let it go. People do funny things. Okay, guys, shall we add this number together before the break? Are you guys fine with this? We'll do it quickly. All right. So 9 minus 5, I'm going to write what 9 is, which we worked out somewhere. It's here. That's 0, 0, 0, 0, 1, 0, 0, 1. Minus 5, we just worked it out at the bottom to be 1, 1, 1. Okay, so this right here is what 9 minus 5 looks like in binary. Just add those two together, we should get the result. Okay, so I'm going to do that quickly. 1 and 1 gives us 10, 0 carry 1. 1 and 1 again gives us 10, 0 carry 1. Just 1 there. 1 and 1 is 10, 0 carry 1. Again, 0 carry 1. 0 carry 1, 0 carry 1. Remember the last 10, we write the entire number down. The last one is a 10, so we write the 10 at the bottom, but we truncate at the end, and we only consider 8 bits. So whatever's left outside of the 8 bits, we ignore it. So whatever's here should be the answer. And that makes sense because that's going to be 2 to the 0, 2 to the 1, 2 squared, so that's 4. That's what we expect in decimals. 9 minus 5 gives us 4. The answer here is 4 in binary, so that worked out. So again, if anyone's confused, we can go over that again, or we can catch it up with the next example. Maybe I should give you guys a break now. It's 10:46. So I took up 1 minute. So take 15 minutes plus. Take 15 minutes. So come back at 11. Come back at 11:02 just to be safe. Yeah. Okay, let me just stop the video.
No, I'm doing that.